We are starting with the projectile motion, and before we get into that, we need to look at the equations of motion and how to actually understand them. So we have four equations of motion. The first one is V is equal to U plus AT. The second one is generally V square equals to U square plus 2AS. Third one is equal to S is equal to UT plus half AT square. And the fourth one is generally is distance is equal to U plus V over 2 into time. Now, all of these equations assume that the value of acceleration is going to be constant, right? So it will be a uniformly accelerated motion, which means that the value of A in all these equations will not change. And some of the common factors that are new over here, S is basically your displacement, but we can use this as distance as well if the direction of distance and displacement are exactly the same. It wouldn't matter. And we are familiar that U is initial velocity, V is final velocity, T is time, and all the other variables we are very familiar with. So only new variable was S. Now we move towards this single dimension motion in which the object is being thrown upwards and then it actually comes down, right? So we're going to try to solve this question with the equations of motion and see what the common questions may be. So let's say that the object is being thrown upwards with the velocity of 20 meters per second. And we are required to find out the maximum height this object is going to go up to. So we're going to label this as h max. And then we are supposed to find out the time of flight. Now, what is the time of flight? So it is going to be the time taken from the first section up to the maximum point. Then from the maximum point to come back down again, this will be, let's say, called T1. This is T2. So the time of flight is actually T1 plus T2. Under ideal circumstances, when there is no air resistance, T1 is actually equal to T2. So what students generally do is find only one time and then multiply this by 2 to find the total time. Now let's try to find out the maximum height. So part A would be the maximum height. So a general idea in this system is that when it does reach the maximum height, the word maximum means that it cannot go any higher. It can't go up, it cannot come down. So momentarily at this point in its life, the velocity going upwards or downwards is basically equals to 0. Only then it starts to come down with its journey. So this is one of the points that we know, and the final velocity is 0. The initial velocity is given to us as 20 meters per second, and we're supposed to find out the distance, but we don't know. And the acceleration is due to the acceleration of gravity, which is g, which is 9.81 meters per second square. Now, the issue over here is this, that the direction of velocity is in the upwards direction, which is the positive one. But the direction of gravity is always acting downwards, no matter if it's going up, no matter if it's coming down. So since the direction of both of them is opposite, we'll have to be careful about them while putting in the equation because both of them are vector quantities. So V square is equal to U square plus 2AS. So V is 0, the final speed going up, and the initial speed was 20 whole square plus 2. Now since the direction of gravitational acceleration is downwards, I'll have to put in a negative sign to compensate for the direction, and S is going to come as it is. Now, sometimes you may get confused that what's going to happen with this negative sign. You see, this is going to come to this side and become negative again. So that negative will be balanced by this negative. So the whole equation basically is going to become positive at the end of the day. So this is going to be 20 squared divided by 2 into 9.81. So the displacement comes out as 20.4. So 20.4 meters. So this will go 20.4 meters high. The second part of the question was to find the time of flight, which I explained to you earlier, that going up and coming down, the times are generally constant in the absence of air resistance. So finding time for just one half can be multiplied by 2 to give us the full time. So time of flight will be involving an equation that has a variable of t in it. We can't use an equation which doesn't have a t. So over here we can use v equals to u plus at, simply put. So this v final speed is 0 while going upwards. The initial speed was 20. The acceleration was negative 9.81 and time t as it is. So t, again, this 20 comes on this side, becomes negative. So this t will be simply put 20 divided by 9.81. So t comes out as 2.04 seconds. So this is 2.04 seconds. Now notice this is the time for the object to go up. So it takes 2.04 seconds to go up and 2.04 seconds to come down. So the total time of flight would simply be multiplied by 2. So the TF becomes 4.08, which will become 4.1 seconds up to two significant figures. Now there's going to be some debate and discussion when you come to the second half. If you had to find the time for the second half, what will be the value of gravitational acceleration and the final speed? You see, the gravitational acceleration and the gaining velocity would be in the same direction, although it's going to be put in negative. But since they are in the same direction, you can ignore the negative sign because it will be automatically balanced algebraically in any equation of motion. We don't have to confuse ourselves by just arguing that gravitational acceleration has to be negative or has to be dealt as a negative sign. We can just simply let it go because they're in the same direction. Or you can simply say that while moving upwards, the gravity is acting against the object's motion, so it has to decelerate. And while coming downwards, the gravity is acting in the same direction, so it's causing acceleration downwards. So both of them can have a positive sign. Although they're moving downwards, should be a negative, but involving negative in arithmetic calculations only may increase the complication. So let's just get rid of that. Okay, so let's say that this initial velocity is given to us, which is at an angle. Now this is going to be a question from projectile motion. You see, this was motion in one dimension. Now this is motion in two dimensions. So the motion in two dimensions is generally called as projectile motion. A very common question. We have practiced questions in this video as well. So let's say that it is being thrown at an angle with a speed of, let's say, 16 meters per second. And let's say that it is happening at an angle of, let's take an odd angle so that there is no understanding between them. So let's say that the angle is 25 degrees, right? So if you were to design components, which we should understand by now by the vector addition method and the vectors, that this component will actually come out as 16 cos of 25, and the upwards component will come out as 16 sine of 25. Now, since it is exactly the same component as this one by the head to tail method, I'm going to write this down 16 cos 25 for this one. So 16 sine 25. What I generally recommend the students is to convert these numbers into their decimal forms so that it becomes easy for us to understand and solve. So 16, and make sure that your calculator is in degree mode. So this comes out as 6.76, so I'm rounding this off as 6.8 meters per second, and this one comes out as exactly 14.5. So 14.5 meters per second forward, right? Okay. Now, again, the questions will be the same. Maximum height is supposed to be found. The time of flight is supposed to be found. And the new question, that is range. How far is this going to go? Okay. Now, first, let's find out the maximum height. This is the most common question. Now, since we want to find out the maximum height, we need to understand how these components work. So let's say that if object was at this stage, the forward component would still be 14.5, but the upwards component would be a bit less than 6.8 because the gravity is acting against it. So the gravity is causing deceleration and will slowly remove the speed while going upwards from this object. So the forward speed is still 14.5, but at this point, the upwards velocity would have lost all of its speed to the deceleration factor. So this will become 0. Only that's why we call this maximum height, because it can't go any higher. So must be that the speed on the upwards direction is 0. Similarly, when it comes to this stage of its lifetime, the forward velocity will still be 14.5, but the downwards component would start accelerating because it's exactly in the same direction as gravity. Eventually, just before landing, the forward component would still be 14.5, unaffected by the air resistance or gravity, and the downward component of velocity will generally come back out as 6.8 meter per second because this is the speed that you released it from. If if this is under the ideal circumstances, when the air resistance is absent. Most definitely, if the air resistance is present, then the answers of both vectors, this 14.5 and the 6.8, both will be affected before they land on the ground. Okay, right. So if this is maximum height, this is only being affected along the y-axis, or sometimes referred to as the vertical component. Why? Because this component is being affected, sorry, only this component is being affected by gravity. If there was no gravity, then the object would never come down and there would be no concept of maximum height. So for maximum height, I should be considering the speed of the vertical axis or the y-axis, which is 6.8 as mentioned at this point, right? So it will be v square is equal to u square plus 2s, exactly the same method that we did for the one-dimensional motion. This is 0 is equal to initial speed upwards is 6.8 whole square plus 2 into negative 9.81 into s. So if this 6.8 goes to this side, this becomes negative, negative, negative cancels out. So we can simply find the displacement at this point. You can do the algebra on your own accord. So this becomes 2.356. So I'm going to consider this as 2.4 meters. So the maximum height, how high it would have gone, is 2.4 meters based on these values, right? The second part is again exactly the same as previous one. That is the total time of flight. How long has it stayed airborne? How long has it stayed in the air? Again, this is also being affected by gravity. If the gravity was not present, it would always go upwards and it will keep going upwards. It will never come back to the land. Since it is only affected by gravity, so I will again involve only the y-axis or the vertical component of my speed in this situation. Now, since we want to find time, we're going to involve an equation that has time in it. So v is equal to u plus at will be used over here. The final velocity is 0. The initial velocity was 6.8 plus negative 9.81 into t. And then again, this comes at this side becomes negative. So no need to worry about manipulating the negative sign. It will cancel out automatically. So this is going to become 0.693. Now, since this is the time to go up, the time to fall down would exactly be the same, 6.93. 0.693, right? So this is the time. So the total time of flight would be the doubling of this single number, 0.693 into 2 is 1.386. So I'm going to write down 1.39 seconds for its whole lifetime. So the moment it starts a journey at this point, goes through this trajectory, till the moment it lands at this point, the total time this object would have consumed or would have used up would be 1.39 seconds. So the last part generally is for the range. How far is this object going to land? If it was released from this location, how far will it go towards this point? So basically, this is what he's asking you. Now, since this range is actually forward motion, so this is moving along the x-axis, or you can say that only the horizontal component is responsible for that. So we are only going to consider that. So the formula is going to become very simple. So speed is equal to distance over time. Now the problem is that why couldn't we solve the range question first? Because we needed time of flight. We needed to know how long is it going to stay in air. So the speed in the forward direction was 14.5. In place of distance, I'm going to write down range because this is what we're trying to find out. And it stayed airborne for 1.39 seconds. So simply bringing this over there, we're going to find out the distance, or you can say the displacement in terms of range like this, simply using the speed is equal to distance over formula. So the answer comes out as 20.115. So I'm going to drive this down to 20.2 meters. All right. So this is how you solve a two-dimensional projectile motion question. Okay. Even for the second half, we need to understand that since the velocity and gravity both are downwards, they will have a negative sign. But even if you employ v equals to u plus at, or you employ v square equals to u square plus 2as, the problem still remains that the negative sign will be balanced out because this negative and this negative will algebraically or automatically cancel out, right? So no need to worry about this one. So while moving downwards, I generally advise the students to take both of them as positive to avoid making an error of calculation by using negatives or negative values in the question. That's all there is to it. Otherwise, the concept remains the same that the value of gravity is always acting downwards. It will always have a negative answer. It is still there, right? It's just a mathematical convenience for the students. Now, this is another type of question that the examiner sometimes asks us, and again, the question would be very simple. Uh, there will be a forward component unaffected by gravity, which will be constant till the end of time, till the end of its motion. And there will be a vertical component which is going to increase with the passage of time, right? So the vertical component keeps increasing, the horizontal component stays constant, and by the end of the day, it will be increasing to a very large value, depending upon the situation, right? So we'll solve a question like this one as well. So let's go towards that. First, we have an MCQ, and he asks us that which graph best shows the variation of t with speed. Now, when the speed is being asked or velocity was asked, that means that the horizontal and the vertical component both are being discussed in the situation, right? So if I wanted to find the resultant velocity would involve both of the components. So it would have a Pythagoras theorem idea. So it would be v cos of theta square plus v sine of theta square and then taking an under root. As we can see, this is a non-linear equation. It will not be a straight line. It cannot be a straight line. So first I will reject option A and B and not even think about it because these are giving straight line answers. And this whole equation doesn't have a single power over it that is going to notify or that is going to let us think that this is going to be a straight line. Second thing, that when it reaches the highest point, the only component remaining will be v cos of theta. And at the end of life, it will be v cos theta and then a v sine theta again, right? So at this point, the resultant velocity would have been the under root of whole square of this one. Or at the end of the day, the resultant velocity, which is at the center, again becomes the square of this plus the square of this and then the under root. So there is never a point in its life when the value of velocity or resultant velocity actually becomes zero. Okay, why? Because the horizontal component, the forward component, is never zero, is never becoming zero. So RV will never become zero, right? So I have to make a choice between C and D. So in D, there is a problem. The problem is that it shows that at some point in time, the velocity becomes zero. Whereas we know that the object is in continuous motion. Its speed is never zero. Its kinetic energy is never zero. So this could not have been the answer. So the question's answer is option C, right? Okay. So speed does decrease with the passage of time. Yes, the speed at the highest point decreases. Why? Because there is only a forward component. The upwards and the downward component do not exist. The resultant velocity depends only on one component. That's why the answer is a bit less than what it could have been at the end of its journey or at the start of the journey, because at the end, this velocity or this speed is because of v cos theta square whole square plus v sine theta whole square and then under root. Both components are involved, so it will be a higher answer. Horizontally in still air from the top of a very tall building, this is the question that he's asking you, that this is the building. The ball is thrown horizontally. So what's going to happen? The ball is affected by air resistance. Most definitely the air resistance is involved. So the horizontal component, this component, and the vertical component both are affected by gravity, right? So this forward component, since it is going to experience drag, this will eventually become zero. So this decreases to zero, right? And the downwards component, while it is moving down, it will be affected and it is being pulled by gravity, but it is going to be experiencing a drag force. So the value of the vertical component will increase because it has started to fall down. The ball has started to fall down, but it will become, or it will take a constant value, right? So it increases to a constant value, not increases at a constant rate. This is wrong. This means that the value of the gravitational acceleration or the value of acceleration is not changing. Whereas we know that if we apply Newton's second law, which is F equals to ma, F opens up as weight minus drag equals to ma. Weight is constant, but the drag is also increasing. So if the drag is increasing, the whole factor starts decreasing and the value of acceleration falls. So it can't be this way. So the only correct answer over here is option B, right? Now we move towards a P2 type question. Initial velocity at an angle is given. He asks us the horizontal component of u. The horizontal component is going to look like this. So this will be very simply put, 12 cos of 50. I advise my students to calculate this completely and write that value over here so that we can use it later. So this is 7.7. The vertical component is this one, it goes up. So this will be 12 sine of 50. So you have to mention 12 sine of 50 over there to show the examiner how you've done this. So this becomes 9.19, but I'm going to write this down as 9.2 meters per second. So this is 9.2 meter per second. So the object is starting to move, or you can say that the initial velocities that it has in the respective upwards direction is 9.2 meters per second, and in the forwards direction it has a speed of 7.7 meters per second, right? Now let's find out what the question. So he says maximum height, and of course this is being affected by the y-axis component only because only that component is affected by gravity. So this is that maximum height that he wants us to find out. Okay, so let's use the equation of v square equals to u square plus 2as. The final speed will be 0. The initial speed going upwards, be advised, the vertical speed going upwards is 9.2 whole square plus 2 into negative 9.81 into s. So when you find s, you get the answer of 4.3, which is shown to the examiner, whatever he wanted from us, right? Okay. Next step would be determine the displacement of the magnetic displacement from PQ. So up to PQ, we need the displacement. I'm going to erase this now. When he says displacement, he's actually talking about the actual displacement. That will be the shortest path from this point to this point. So this is going to be a triangle, right? We have found the maximum height, which was 4.3 meters, but we don't know this distance. To make it a right angle triangle, we don't know this distance. So what we're supposed to find out is the range, as done earlier. What to find the range, but for range, we need to find the time it took to go to that point. So since it was time for the maximum height, so we can use v equals to u plus at to find out the time. While going upwards, its velocity would be 0, equals to the initial speed at which we throw it upwards is 9.2. So this is 9.2 plus gravity is acting against it, so 9.81 negative with t. So t is equal to, again, 9.8 comes to this side, becomes negative, negative, negative cancels out. So we don't have to worry about that. So 9.81. Answer of time comes out as 0.937. So I'm going to round this off to 0.94 seconds. So it took 0.94 seconds to start his journey from this point and land eventually at this point. So even for the horizontal component, you have allowed a time frame of 0.937 seconds. And we know that the forward velocity is actually 7.7, the horizontal component. So let's find out the range that it has taken. So to find range, we simply use the formula speed is equal to distance over time. Speed has already been found. The horizontal speed is already known. The horizontal speed is 7.7. So S is 7.7. T is 0.94. And then we can find the D. So if we find out the D, that comes out as 7.7 multiplied by 0.94. This gives us 7.238. So this will become 7.3 meters. So this will 7.23. This will become 7.24 meters. Now what the diagram looks like now is that this is the point where it actually starts the journey P and goes to Q. So this is P. Actually, it takes a curved path But since we are looking for displacement, it will be the shortest path, right? So it can be solved like a Pythagoras theorem problem. So this is Q. So this range or half range has been calculated over here. This is 7.24 meters. Just found this out. And this was found in the previous part, which was 4.3 meters. Okay, now this is a right angle triangle. We can find out the hypotenuse. So the displacement from P to Q is actually equal to under root of 4.3 square plus 7.24 square. So the displacement from P to Q is equal to, so you can calculate this on your own time. It comes out as 8.42 meters, which is going to become 8.4 up to two significant figures. So this displacement, the shortest path would be 8.4 meters, right? Moving on to this question. This question exactly like the example that we just saw about this building. That's why I didn't elaborate it over here, because we are going to do this question to understand how this is going to happen. So mass of the ball is given to us, because the next parts would involve the kinetic energy or gravitational potential energy, but we are not required to find this right now because the lesson is about projectile motion. So it has given us some heights, some distances, and some range. So you can see this is the range and this is the maximum height, right? So it tells us that we need to find the horizontal velocity of the system, okay? So we have 1.25, how it's going to fall. Now, the initial point or the initial velocity of this object, if I draw it over here, most definitely it has a forward component of v, but the downwards component is actually 0 at the beginning of its life. Only when it actually experiences gravity, its downward component will start existing, or it will start forming. So we can assume that the initial velocity coming downwards was 0. So v is equal to u plus at. If you wanted to use this equation, the v in this case would be 0. The initial velocity, sorry, not 0, but we want to find this out before it falls or hits the ground, right? That velocity, initial velocity will be 0, and the acceleration will be negative 9.81, and then that is the time t to fall down, right? Now, we can't use this equation because we don't have one of the variables, which is t. So what we're going to do, we're going to employ another equation, which is v square is equal to u square plus 2as. So our final velocity is what we want to find out, so that we can put in this equation to find time. And the initial velocity is 0 squared plus 2, and it is moving in the presence of air resistance, which is negative 9.81. And the displacement downwards is 1.25. So 1.25, and now there is a problem. This is why I was encouraging that if you are moving in the second half of the projectile motion, let's say in this situation, since both of them are in the same direction, I would advise you to take all of them to be positive. Because now we encounter the next problem. The problem is that we have an equation that has a square, and on the other hand, we have a negative value. You can't take the under root of a negative value. So since both of them are actually moving in the same direction, I'm going to assume this to be positive because both of them are downwards. So this is going to become a 2 into 9.81 into 1.25. There is another equation you could have used to solve this, to find the time, that is s equals to ut plus half at squared. We could have done that as well. We're going to look at it that way as well, so that we can fully understand all the equations and all the way outs of the system. So that would be 2 into 9.81 into 1.25, and simply under root the answer, that would be 4.95. 4.95 meters per second. So that is the downwards velocity, right? So this was going to come out as 4.95 equals to negative 9.81 into t. T would be equal to, of course, this is negative because it's coming downwards, divided by 9.81. This will give me a time frame of 0.51 seconds. So it will take 0.51 seconds to come down. Now, since we were trying to find out the forward component, the time that we found for flight is exactly the same time for both components. We have only allowed 0.51 seconds for the vertical component to exist and for the horizontal component to do its job of carrying the object up to 1.5 meters away from the table, right? So over here, what we could have done is simply apply Speed is equal to distance over time. So speed multiplied by time will be the simplified version. So we know that, sorry, we want to find speed. So let's keep it that way. So speed is equal to distance over time. So distance in this case is 1.50 meters. Time is 0.51. So the speed comes out as 1.5 divided by 0.51. That is 2.94. So this is 2.94 meters per second. So the forward velocity actually comes out as 2.94 meters per second, right? Now let's look at this idea that how we could have found time using this equation. Again, it's all about concept. Here you will encounter another problem that we can't put the acceleration's gravity value to be negative. Although some students and some teachers do argue that over here you could have used a negative sign to balance out the negative sign of the gravity, but we don't have to get into this debate that this accuracy leads to the same answers. So if gravity is downwards and the velocity gain is downwards, then keep them both positive and then solve the question. We don't need to get into those other ideas. Okay, so S will be 1.25. Why? Because only this height, 1.25, is responsible for making sure that the object stays airborne. Why? Because this displacement is being affected by gravity, right? So we will be taking this S because this will be involved in the time calculation. Now, since moving downwards, the initial velocity is 0, this U will be 0, so this whole factor becomes 0 plus 1 over 2, since it's moving downwards, it will be 9.81 into t squared. Now, again, there is a problem. The problem is, if you take this negative 1.8 over to this side, this becomes a negative value, and the under root of a negative value cannot be calculated. Now, again, conceptually speaking, since the object is moving downwards, this is its starting point and this is its ending point. The displacement is downwards will be taken negative as 1.25. So in place of 1.25, I should have placed negative 1.25. This whole becomes 0 plus 1 over 2 into negative 9.81 into t squared. Now, conceptually speaking, the negative sign cancels out and you won't have to worry about taking an under root of a negative value. But again, I am enforcing this point again and again because it doesn't help the purpose. It doesn't help a situation in which things can be kept simple. For the sake of argument, for the sake of scientific discussion, it's fine. But I'm supposed to help you to simplify the problem so that you can find the answers. So I prefer to solve it this way by keeping everything positive if they are in the same direction. Okay, so t in this case also comes out as 0.51 seconds, exactly the same time as this one, right? So you could have used that equation and then come down to this point. But I prefer it this way. Why? Because we eventually need the downwards velocity as well. So since we need it in the next part, or even if we don't, we may suspect that it's going to be part of the next question. So that's why I've found it over here already. Now it tells you to find out the final velocity, the magnitude of final velocity, and the angle with the horizontal. Now, when the ball actually hits at this point, we need to find the resultant velocity, right? So let's clear out everything. So there is going to be a forward velocity component and there is going to be a downward velocity component. We've already calculated the forward component, which is 2.94, and the downward was already calculated as 4.95. So this is 4.95 meters per second, and this is 2.94 meters per second. The resultant velocity is going to be exactly visualized in way of the Pythagoras theorem that we already do. And the angle is with reference to the horizontal. Okay, so this is my horizontal point. So the angle that he's asking me is expected to be found or is expected to be located at this point. So this angle x is what he's asking me. So what I can do is use the Pythagoras theorem idea and remove this vector from this location and just head to tail method and replace it over here. So this is 4.95, I guess. Yes, 4.95 meters per second. Now it becomes easy to look at. Now it becomes easy to solve. So the resultant velocity will be calculated by the Pythagoras theorem, which will be under root of 4.95 square plus 2.94 square. What you will find generally in books and notes and in some classes as well is that teachers generally don't convert this into the respective value. They take the v cos theta completely into the systems. I don't like that because it's easy to visualize values than to visualize v cos theta. Just an example, right? So this will be 4.95 whole square plus 2.94 whole square, and then take the under root. So the final resultant velocity comes out as 5.75, which will be rounded off to 5.8 meters per second. And to find this angle, we can use the tangent, the tan theta formula. So tan x will be equal to 4.95 divided by 2.94, and then inverse of that over here. So x comes out as 4.95 divided by 2.94, shift tan inverse. We are getting the angle 59.9. So 59.9 degrees. I'm going to round this off to 60 degrees, and the final answer as 5.8 meter per second. I hope that the issues are clear in projectile motion. That is all for today.